Right, so in today's tutorials, we want to look at how to do exploratory data analysis in STATA. So to begin with, we'll be making use of the do file instead of the command window. Okay, the do file is basically like a script file where you can list and execute STATA commands, and you can get it by clicking on the new do file editor. Okay, so once you click on this, you can basically get a do file, and this will help you to also keep most of the commands to be used in the future. Okay, so it's very important we make use of this. I already have one, so let me close this and open that. So let me jump to the open. So this is where I have my do file. I'm going to open that. Alright, so this is what I want to use. Let me drop the do file editor on one side of my window. Okay, so that I can see the result window. I can see my result in here. So the asterisk is basically used for commenting, right? Or the double forward slash is also used for commenting. Okay, so the first thing that you would like to check is your working directory. So you want to check working directory. Okay, so to check your working directory, you can use cd, this function. Okay, so let me execute it, Control D. So this is my working directory. This is where I have my do file and the data file as well. Okay, so maybe if you want to set a new working directory, then maybe let's say you want to set a new working directory, then you can use cd, okay, and use double quote and paste the path in this double quote. So how do we get a path to the folder? Let's, for instance, this is where I have my data file together with a do file. So once you click on this, you can get a path. Click on right click and copy this. Okay, so you can go back to your do file. So once you go back to your do file, you can paste it in this double quote. So let me paste. Okay, so once you do this and you execute this, you are going to set a new working directory. I'm going to leave the data file together with the do file in the description of the video so that you can download it. Okay, so let's proceed. So once we have set, I've already set, so I don't need to run this again. Once we have done this, we can then get started. Let's import our data set. So I want to import data set. So to import your data set, we are going to make use of the import delimited because this is a CSV file. Okay, this function, the import delimited, is basically used for reading text files with clearly defined column delimiters such as commas, tabs, semicolons, or space. Okay, so once we have done this, we can then write the name of our data set. So the name of the data file is iris data. Okay, I'm going to leave this in the description of the video so that you can download it. Then the file extension CSV, and you have to use the clear function to basically clear any existing data that you may have in your STATA. Okay, you can either do it this way or you can clear this and try and write it before the import. So I can write it this way. Okay, each way you will get the same result. So let's quickly run this, Control D. So let's flip to our result window to see the effect. So we can see that we have 5 variables with 150 observations. So how do we see our data set? So let's get a view of our data set. So we're going to use the browse function. Okay, browse. This is to view data set. Okay, so let's highlight this and run. Control D to execute. Okay, so here we go. This is our data set. Okay, this is the iris data set. The iris dataset was introduced by Ronald Fisher. This dataset consists of 50 samples from each of the 3 species of the iris plant. We have one of them to be setosa, we have versicolor, and we also have virginica. Okay, and 4 features or 4 variables were measured from each sample, which included sepal length, sepal width, petal length, and petal width. So based on the combination of these 4 variables, Fisher developed a linear discriminant model to distinguish the species from each other. This is the data set that we want to use for the exploratory analysis. Okay, so let's get a feel of our data set. Let's get to know the structure of our data set. So let's go back to our results, the do file. So now I want to get the structure of my data set. So let's use the describe function. Describe, okay. So I want to get structure of data set. So let's highlight this and execute. Control D to execute, or sometimes you can use this icon, okay, to execute it. So I'm using the shortcut Control D. Then I'll flip to my result window to see the effect. So I have 150 observations, 5 variables, okay, and we can see the variable names together with the storage type, sepal length, sepal width, petal length, and petal width. They are all float or basically numeric. Species is string, okay, but we know that most of the analysis with the software does not require string, so we are supposed to encode or recode this to a numeric in our data preparation stage. So we'll be dealing with this very soon. Okay, so I think we are good to go now. So now we can start with our data preparation. Why do we have to do this? Because we have to basically do this in order to clean the data so that it becomes ready to be used for analysis. Okay, so data cleaning is something that's very important. So let's enumerate this: data preparation or cleaning. Okay, so we have to basically clean or prepare our data before we start with our analysis. Okay, anytime you want to conduct any analysis, make sure that you always use this stage. You have to pass through this stage, which is the data preparation stage. It's very, very important. So what are some of the things that we can do under data preparation? We can basically check for some missing values, also some duplicate values, and also recode or do some manipulation in our data set. Okay, so let's start with checking for missing values. So 1.1, want to check out, check for missing. So check for missing values. Okay, so how do we check for missing values? We are going to use the function mdesc. Okay, this function will give us information. So it gives our information regarding missing values. Okay, alright, so you can basically, if you don't have this, you can use the search function, type the name mdesc, okay, so that you can basically search and basically install it if you don't have it. So let's run this, Control D. So let's see the effect in our results window. So we can see that sepal length, sepal width, petal length, petal width, they all have one missing value, but species doesn't have any. Okay, so how do we deal with missing values? There are 2 ways or 2 methods that we can use. We can either use the data imputation method or we can use the delete method. Okay, so let's look at the data dealing with missing values. So one method that we want to look at is data imputation. Okay, so with data imputation, let me use the data editor to illustrate. With data imputation, we are basically going to replace the missing value for this with the average value for this variable. Okay, we'll do the same for this. Sometimes this method is actually the best method to use, especially if your missing value is located at different entries. So let's say you have 1 year, you have one missing value here, you have one missing value here, you have one missing value there, then using the data imputation method is the best. Okay, but if for instance you have all the missing value in the same entry like this, then basically you can use the delete method. Okay, so we'll be making use of the delete method, but I would like to illustrate how you can go by the data imputation method instead. Okay, so let's go back to our result do file. So with data imputation, let's get a mean value for our variable. Let's say we want to let's start with that of let's start with that of the sepal length. So let's get a missing value. Sorry for that. So let me close this. So go back. Yep. So I'm using the sum function to get the average value. Okay, sepal length. So to get the mean value. Okay. So let's see for sepal length. Control D. So here we go. We see that we have 5.85. Okay. So we want to replace the missing value with this average value. So I'm going to say replace sepal length, which we have assigned it as 5.85, if this sepal length is basically a missing value. Okay, so we use the double equality sign to show that it's equal to a missing value, and the period sign here right shows that we have a missing value instead. So let's try and execute this with see the effect. Control D. Okay, so let's check our data editor. So we have seen that this has been replaced with a missing with a mean value. You can do the same for sepal width. You can do the same for this. Okay, you just have to get a mean value. For parametric methods, using the mean value is good, but if you are looking at non-parametric methods, then you can use the median value to replace the missing value. Okay, so I think we are good to go. So let's go back to our do file. Okay, so you can do the same for the other, let's say sepal width. Okay, so copy this and just paste. Okay, so just change this to sepal width. Okay, so once you get the mean value, you just change this to sepal width. Okay, and change this to, so let's say you have a mean value of 2.15, then you change this to sepal width. Okay, then it will work. Okay, now I don't want to use this method. Okay, so I don't want to use this, but let me run this and see. Control D. Let's check our data editor. So is it working? Sepal width. Okay, sepal. Oh, that is spelling mistake. Sepal width. Okay, so let's rerun this again. Control D. Let's see the effects. So we have seen that we have replaced the missing value with this. Okay, but we are not going to use this method, so I'm going to basically I want to ensure that this place are missing values, so let me replace everything with the missing value. So I'm going to say replace. Okay, replace if sepal length right is no, let me use replace sepal length. Let me use this method, replace sepal length being assigned as a missing value, right, in row entry 14. Let me copy this and paste. Do same for sepal width. So this should be sepal width. Okay, so replace sepal width assigned as a missing value in row entry 14. So let's execute this. Control D. Now let's flip to our results, the data file. Do we see any change? We don't see any change, right? I think spelling mistake, length, right, and the width, sepal width. I think this is okay. So let's rerun it again. Control D. Okay. So you can see now everything has been replaced with the medicine value. So this was our original data set. We want to use the delete method because we have the missing values in the same entry, so deleting it wouldn't have much effect on the sample size. Okay, so let's look at the second method, which is basically the delete method. So I want to use the delete method. So using the delete method, we are going to use a drop function. Say drop if sepal length is assigned or is equal to a missing value. Okay, so I'm going to copy this and do same for sepal width. Okay, so sepal width, right, and let me copy these two and do same for petal length, and let's say petal width. So this will be petal length. Okay, and be careful with the spellings, petal width. Okay, so let's try and execute this. This is only useful if you have the missing values in the same entry, and you know that the missing values are not too many. Okay, if the missing values are too many, then it's advisable to use the data imputation method. So let's try and execute this. Control D. Okay, so let's go back to our data editor. So row entry 14 has now been removed, so we have a different entry altogether. Let's check this in our result window. Let me use the describe function to see the effects. Okay, so let me use the describe function. So say describe. Okay, let's execute this to see the structure of our data set. So now we see that we have 149 observations and 5 variables. Okay, so we are good to go. So the next thing that we can also look at in data preparation is to check for duplicate values. So let's do that. So this is going to be 1.2, right? So I want to check for duplicate values. Okay, so how do we check for duplicate values? We can use the duplicate function. So duplicate and use the list to basically get the values with duplicate. Okay, so let's execute this. Control D. Let's flip to our result window, and we can see that row entry 101, 142, they are the same. Okay, so this is a typical example of a duplicate instance. So how do we deal with this? By default, STATA assumes that the first entry is the correct one and the second one is the duplicate. So it's going to basically keep this and remove the last one. Okay, so let's drop the duplicates. So I want to delete the duplicates, so I'm gonna say duplicate drop. Okay, so this is basically going to remove the second entry. right, of the duplicate. So we have seen the duplicate is going to remove the second one, okay, or the last one. So let's run this, Control D. Okay, let's check in our data editor. So we can see row 101, 101. We still have that, right? But 142, if we scroll to 142, we have different entry altogether, okay? Yep, so I think we are good to go. Alright, so let's use the describe function to see the structure now of our data set. So I'm gonna say describe. Okay, let me see the structure of our data set. So we now have 148 observations, okay, and 5 variables, okay. So I think we are good to go. Now the next thing that we want to look at is to convert this string to numeric, right? We want to basically assign labels, assign values to the labels of the species, okay. So let's look at how we can do that. So still under data preparation, I want to check this time 1.3 convert. Want to convert a string variable, okay, to numeric. Okay, so before we do that, let's basically use the code book to get a more detailed description of our variables. So code book, and let's pick the species. So when you execute this, let's see what you're gonna get. Highlight this and execute, Control D. So we can see that for the species, the data type is string, but we don't need this because anytime you want to analyze this, you may have some challenges. We want it to be numeric, and these are all string, okay. But what we want to do now is to basically assign some values to these labels. I've already explained in our introduction to statistics that for categorical variables, you can assign numbers to them, and the purpose of assigning numbers to these labels is for identification purpose, okay, so that it can also help us in our computation or in our analysis, okay. So sorry for my voice. Basically we assign numbers to these labels so that we can also use it in our computation, okay. So let's go back to our do file. So now what I want to do is to use the encode function. So encode, right, this function will basically create a new variable based on a string variable, okay. So species, I want to encode species, but I want to generate a new variable, okay. I don't want to overwrite this species variable, so I want to get a new name for this species variable. So I want to name this species 1, okay. So let's try and run this, Control D, and now let's get the description, describe to see the structure of our data set, Control D. Alright, so let's check our result window. So now we can see that species 1 has now been converted to long, which is the same as numeric, okay. So we have now assigned values to the labels of the species variable, okay. So let's use the code book to get a more detailed info of our species variable. So let me say code book, right, and now I want to use species 1, okay. So let's highlight this and execute, Control D. Let's see the effect. So we can see now the data type for species is now numeric, okay, and we have basically assigned 1 to Setosa, 2 to Versicolor, and 3 to Virginica. So this is now appropriate to be used for analysis compared to the previous one, okay. So let's go back to our do file. Now let's say we want to drop this species. Okay, we don't need a previous one so that we can maintain this. So now let's drop the species variable. Okay, so let's use drop drop species. Okay, so this is to delete the species variable. Okay, so let's execute this. Control D. Now let's get a describe function to see the structure of our data set. Control D. Let's flip to our result window, so we can see that we have omitted the species that we're having. That's the one with a string type, and we have maintained the one with a numeric. Okay, so we are good to go. We can also rename this variables. Okay, so let's try and rename. So let's say I want to now rename our variables. So let's use a rename function. So rename sepal length as XL, SL for sepal length. I can copy this. Oh, sorry. Let me go back. Copy this. Okay, and paste. Right. Let me change this to sepal width. Okay, sepal width as XSW. Okay, let me copy this too. Right, and paste it, and change this to petal length, and this should be petal width. Okay, so let's change this as PL. Right, and this should be PW. So let's try and execute this. Control D. Now let's let me add one more. Rename species. Right, species 1 as SP. Okay, so let's execute this. Control D. Now let's use the describe function to see the effect structure of our data set. Control D. Let's flip to our result window so we can see that we have renamed our variables. Okay, so we are good to go. Alright, so I think we are we are good to go. So before we start with our exploratory analysis, there's one thing that I also like to talk about, which is with regards to data filtering. Sometimes you may not want to use all the variables or all the values in your data set. You would like to basically filter some of these observations. Okay, so in that case, using the filter method or data filtering becomes very important. So how do we filter our data set? So we are going to use the edit mode, right? This icon. So you can click on that. Okay, so yes, just click on yes. Okay, so we are going to use this edit mode to basically filter our data set. Sometimes if you are not interested in using all the observations or all the variables, then data filtering becomes very important. So first of all, let's save this because we are going to use this data set for our expert analysis. I think we are done with the data preparation. Okay, so let's save this as a clean data. So save. So it should be in your current folder or working directory. Okay, so let's name this as clean dat. Okay, and the extension should be DTA. So let's save this. We are good to go. Okay, so now let's click on the filter observation icon. Right, click on this. to filter out your data and scroll down, click on this, okay, and pick variables. So let's assume we want to select only the species type. We want only STATA and Virginica. Okay, so let me click this. Okay, so once I do this, I can use double equality sign. Remember that you have assigned values to the labels. One is for STATA. Okay, so this means that I'm interested in the STATA species. Then I can use the OR operator. Okay, this symbol. Okay, then type again. SP should be equal to 3. So this is basically mean that we want STATA and Virginica for all the variables. So let's click on OK. Right, then apply filter. So let's see the effect now. So you can see that now we only have STATA, right, and that of Virginica. We don't see vesicular in this. Okay, so and let's try and add one more condition. Let's assume for sepal length, you can see that most of the values are greater, or let's say some are below 5, some are greater than 5. So let's say we want to add a condition to this. We want a situation whereby for this selection of our data set, the sepal length values will be greater than 5. Okay, so let's go back to this, click on the variables. Okay, so let me close this with parentheses. Alright, so I'm going to use the AND symbol or the ampersand. Okay, so now I want to add another condition and say the sepal length should be greater than 5. Okay, so let's click on OK and apply filter. Okay, so now let's see the result. So we can see that all the values are greater than 5. If you scroll up, see all the values are greater than 5. Alright, so we are good to go. So let's assume now we don't want to use all the variables. We are interested in just 2 of the variables. And then we can click on, maybe we are not interested in this, so right click on this and hide selected variable. Okay, you can do the same for this if you don't want to use it. So right click and choose hide selected variable. Okay, then we are good to go. Okay, but don't save this. Okay, don't save this, just close this. Okay, don't save this. We are going to use the original one. So let's say filter, just remove filters. Okay, and close this. Don't save. Okay, let's open the browser again. Yep, so we want to use this for analysis. So this is the clean data. Okay, this is the data set that we'll be using for the exploratory analysis in our next tutorial video. I hope you stay and stay.